Hello everyone and welcome to my channel Easy Maths. Today I'm going to talk about the basics of trigonometry. Now the basics of trigonometry I've divided into two videos. So this is the first video which I have called Trigonometry Part 1. Now what I have done here is I have drawn a right angle triangle. Now let me tell you, we will start the concept of trigonometry with a right angled triangle. Though trigonometry can be applied to any kinds of triangles, then why have I chosen only a right angled triangle? This is because when we start with trigonometry, a right angled triangle is required. That is, to understand the basic concepts, a right angled triangle is required. Now trigonometry can be applied to any kinds of triangles. Those things we will learn later on. So to understand the basic concepts, I have taken this right angled triangle and I have named it triangle ABC. As you can see, B is a right angle here in this triangle. That is, the magnitude or the value of B is 90 degrees. Now the first thing which I want to say is, you must know that, you must be knowing it, that the side which is opposite to the right angle is called the hypotenuse. So let me write it over here. It is called the hypotenuse. So every right angled triangle has a hypotenuse. Now what I will do, another thing I'm going to do here is name this angle as theta. Now theta, it looks like this. It is actually a Greek alphabet. Now in maths and similar scientific subjects like physics also, we use quite a lot of Greek alphabets. Okay, that has been the convention. So instead of theta, we could have used anything else. Okay, we could have used alpha, beta, gamma, or we could not have used any Greek alphabet. We could have just said angle C. Okay, but why it is done? To make things easier. Now there are certain ratios which are to be learnt in trigonometry. There are actually 6 ratios. So I'm going to write all the 6 ratios. And again, I've said it before also. If you feel that you want to take a screenshot of something, you can just pause the video and take. So I'm going to write about the 6 ratios. The first ratio is sine. Then we have cosine. Then we have tangent. Then we have cosecant. Then we have secant and cotangent. These are just the names of the 6 ratios which we have to learn. Now still some of you might be wondering, what are these? Okay, I have just said that these are ratios. Now what kind of ratios? Now when I say a ratio, it means a ratio only. That is, something is to something or something by something. Now let me tell you another thing. These names, when we do the sums of trigonometry, these names we don't write in full. We use short forms. Like for sine, we write sin. For cosine, we write cos. For tangent, we write tan. For cosecant, we write cosec. For secant, we write sec. And for cotangent, we write cot. Okay, this is just to simplify our working. Now let's understand the meanings of these ratios. While we try to understand the meanings of these ratios, let me tell you, these ratios will be defined by me now. Now the definitions of these ratios must be remembered by you. We take sine of an angle or cosine of an angle. Please remember this. Any of these 6 ratios, we take that ratio of an angle. Let us say we take the ratio of the angle theta here. That is let's start with sine theta. Now this ratio sine, and I'm taking this theta. When I write sine theta like this, it is actually meaning that theta is an angle and sine theta is a ratio, or in other words, sine theta is a function of theta. Those who have studied in class 9, you must have done some chapters which deal with functions like f of x, function of x. You must have done in polynomials or in factor remainder theorems. So sine theta is kind of a function of theta. Now let me tell you what sine theta actually means here. So now I'm going into the definition of it. Sine theta equals opposite by hypotenuse. Sine theta equals opposite by hypotenuse. Now opposite of what? Opposite of theta. In many books I have seen it's written sine theta equals to perpendicular by hypotenuse. I think this is a better way to remember it, because students often get confused about which is the perpendicular and which is the base. Now let's not use words like perpendicular or base here. I will use the words opposite and adjacent, and hypotenuse is of course there. Now when I say sine theta, this is theta, so sine theta means opposite by hypotenuse. Opposite of what? Opposite of theta. Now opposite of theta is this side AB. Everybody should understand this. The opposite of theta is this side AB, and the adjacent to theta is this side BC. I think this should be clear to all of you. So sine theta equals to opposite of theta, that is AB by AC. In this figure it is AB by AC, but everybody should remember sine theta is opposite by hypotenuse. There are certain things which you should memorize, okay? One of them is this. Next we come to cos theta. Cos theta equals to adjacent by hypotenuse. That equals, so adjacent to theta is the side BC. So it is BC by AC. I hope it's clear to you. Then we move on to tan theta. See, these are just the definitions. Please remember these definitions. Tan theta equals to opposite by adjacent. That equals to AB by BC. So till now we have learnt 3 out of those 6 ratios: sine theta, cos theta, tan theta. So sine theta means opposite by hypotenuse, cos theta means adjacent by hypotenuse, and tan theta means opposite by adjacent. Now let's move on to the other 3 ratios. We have cosec theta, meaning now we define cosec theta, which means hypotenuse by opposite. Remember, we had sine theta equals to opposite by hypotenuse. So cosec theta is hypotenuse by opposite, that is cosec theta is actually the reciprocal of sine theta. So I can write hypotenuse by opposite, that equals to AC by AB, right? So the next one, sec theta equals to hypotenuse by adjacent. Again, let me remind you, cos theta was adjacent by hypotenuse. Now sec theta is hypotenuse by adjacent, so it is AC by BC. I hope it's clear till now. Now we are left with the last one, cot theta. Cot theta is adjacent by opposite, so it is adjacent by opposite. That equals to, so adjacent to theta is BC and opposite to theta is AB. So in this triangle, cot theta equals to BC by AB. Now see, as I have told you, cosec theta is the reciprocal of sine theta, because cosec theta is hypotenuse by opposite and sine theta was opposite by hypotenuse. So cosec theta is AC by AB and sine theta was AB by AC. So I think we can easily write cosec theta equals to 1 by sine theta. So we just take the reciprocal of sine theta, which comes out to be 1 by sine theta. For sec theta, cos theta was BC by AC, that cos theta was adjacent by hypotenuse. Sec theta is hypotenuse by adjacent, so it is the reciprocal of cos theta. So we can write sec theta equals to 1 by cos theta. Okay, and cot theta is adjacent by opposite. Now tan theta was opposite by adjacent. Now cot theta is adjacent by opposite, so it becomes BC by AB cot theta. So that can be written as 1 by tan theta. So you see, while we learned the definitions, there only we learned 3 formulas. These are the first formulas of trigonometry. That is, cosec theta equals to 1 by sine theta, sec theta equals to 1 by cos theta, and cot theta equals to 1 by tan theta. I hope it's clear up to here, all of you. Again, let me tell in the middle of the video itself that if you have any doubt regarding any concept or whatever I am teaching, don't forget to comment it in the comment section below. I'll try my best to answer your queries. Now we move on to some simple problems. Okay. For example, let me erase this also. Suppose I take this triangle ABC and say the length of this side is 4 centimeter, this is 3 centimeter, and this is 5 centimeter. Now let me give you one simple problem. In the triangle ABC, find out the values of number 1 sin theta, number 2 cos theta, number 3 tan theta, number 4 cosec theta, number 5 sec theta, number 6 cot theta. That is, from this triangle you have to find out each and every value. Now let's see, we come to the solution. Number 1, we have to find the value of sin theta. Now sin theta equals to, you must remember, sin theta is equal to opposite by hypotenuse. Now the opposite side of theta here is 4 centimeter and the hypotenuse is 5 centimeter. Now 4 centimeter and 5 centimeter, so it must be 4 by 5. So you see that sin theta is actually a ratio, that is 4 by 5. Now the next one, cos theta equals to adjacent by hypotenuse. So adjacent to theta is 3 centimeter and hypotenuse is 5 centimeter. So that gives us 3 by 5. So cos theta in this triangle is 3 by 5. Part 3, tan theta. Now tan theta equals to opposite by adjacent. So opposite to theta is 4 centimeter and adjacent to theta is 3 centimeter. So 4 centimeter by 3 centimeter, which gives 4 by 3. So sin theta, cos theta and tan theta we have found out. We are left with cosec theta, sec theta and cot theta. Now once we are done with sin, cos and tan, cosec, sec and cot becomes very easy because they are just the reciprocals of these ratios. So I am writing here itself number 4. Cosec theta equals to 1 by sin theta. That equals, now 1 by sin theta means the reciprocal of 4 by 5. That is 5 by 4. Sec theta equals to 1 by cos theta. That equals to the reciprocal of 3 by 5. That is 5 by 3. And tan theta equals to, cot theta equals to the reciprocal of tan theta. So cot theta equals to 1 by tan theta. So the reciprocal of 4 by 3, that is 3 by 4. I hope it's pretty clear to all of you. I think I've been very simple in explaining this. Now I want to show you another example, or you may say this sum only with a different figure. Now see, I'll just erase the solution part and I'll just erase this. Okay, so I remove one information from the question, that is from the diagram. In this triangle ABC, find the values of sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Now here we can see it's a right angled triangle ABC because the symbol of this right angle is here. You must follow that. Now here when we find sin theta, we have to find opposite by hypotenuse, but the hypotenuse is not given in the question. So what can be done is, I think all of you are aware of Pythagoras theorem. If you are not aware of Pythagoras theorem, then the solution of this sum will be a bit difficult for you. But I think all of you are aware with Pythagoras theorem. So with the help of Pythagoras theorem, we can first calculate the length of the hypotenuse because the other two sides lengths are given. So in this case, the solution would be like this. We first find the hypotenuse, that is AC, equals to square root of AB square plus BC square. Why are we finding this? Because we need it. We need the hypotenuse, otherwise we won't be able to find the ratios. So that is 4 square plus 3 square. We must write a centimeter here outside the square root symbol. That equals to 16 plus 9. That equals to square root 25 centimeter. That equals to 5 centimeter. Now one thing must be kept in mind, whenever we do square root of a number, square root of a positive number, we actually get a plus and a minus. That means, in other words, square root of 25 should be, it should be plus minus 5. Okay, because minus 5 whole square also gives 25. So square root 25 has two values, plus 5 or minus 5. But here we will take only 5 centimeter. That is, we will take only the positive value because it is the length of a side of a triangle which cannot be negative. So we take 5 centimeter. Now let's come back to this problem. See, now we have found out AC. So that is the hypotenuse is obtained by us. So now we can easily move on with this. Now the rest of the sum, which I am not showing anymore because I just showed the sum with the value 5 centimeter written here. The rest of the sum is like that only. Okay, now let me tell you another thing. In this sum, if somehow 5 centimeter was given and BC, the length of BC was not given, then could it be done? The answer is yes. Again, using the Pythagoras theorem, we could have found out the length of BC. I'll just show you how. That is also very easy. Since BC is not there, so BC must be found out. Now we know that AB square plus BC square equals to AC square. This is by Pythagoras theorem, or this implies that BC square equals to AC square minus AB square, right? That implies BC equals to square root of AC square minus AB square. I think that is pretty clear to all of you. So BC equals to square root of AC square minus AB square. So in this sum it will be square root of 5 square minus 4 square. That equals to 25 minus 16 square root of that. That is square root of 9. That equals to 3 centimeter. I hope it's clear. So out of these three values, if any one value is missing, we can find that value using the Pythagoras theorem, because this is a right angled triangle. But remember one thing, had it not been a right angled triangle, then this could not have been done. So since I am starting with the basics of trigonometry, we can easily do this kind of sums when a right angled triangle is given. With that, I will end this video, and in the next part, that is trigonometry part 2, we will learn some more formulas, or rather should I say, we will learn some more identities of trigonometry, and we will learn some more sums and more application based on those identities. Before I end this video, let me tell you, please share this video if you really like it. Do press the like button and share it among your friends and whoever you think is relatable to this video, and don't forget to subscribe to my channel and press the bell icon for notifications. Thank you so much.